Chemical reactions and equations. In this lecture, I will teach you the super easy concept of chemical reactions and equations. So watch this lecture till the end and you will learn something very special. Now what is physical change? Well, consider this glass bottle. Let it falls and breaks down into several pieces. Here we say that the shape and the size of the bottle is changed, but no new substance is formed. For example, the particles of the bottle are still glass and no new substance is formed. So we say that it is a physical change. Secondly, consider water in this pot. Let I add some sort of sugar to it. We get sugar solution. Here we again say that the shape and size of the sugar change, but no new substance is formed. For example, the sugar still retains its sweetness in the water, or sugar shows its presence in the water. So it is a physical change. Thirdly, consider some vegetables. Let you cut these vegetables into several pieces. Here we say that you change the shape and size of the vegetables, but you do not form something new. For example, the small pieces of the vegetables still retain their property. I mean, the small pieces of the potato is still potato. So it is a physical change. Fourthly, remember these physical changes like melting, boiling and freezing. These are all physical changes. Therefore, we define physical change as the type of change in which only physical properties of matter change is called physical change. For example, like color, size, solubility, etc. Thus noted down these examples of physical change. Now what is chemical change? Well, consider these burning wood. When you burn them, the wood changes to produce carbon dioxide gas and water vapor. Here we say that new substances are formed. For example, carbon dioxide gas and water vapors are formed from the wood. So burning wood is an example of a chemical change. Secondly, consider digestion process. Let you eat enough carbohydrates in the food. Now the enzymes in your intestine convert these carbohydrates into glucose. Here we say that new substance is formed. For example, glucose is formed from the carbohydrates. So digestion is an example of a chemical change. Thirdly, consider respiration. Inside your cell, the glucose in presence of oxygen is converted into carbon dioxide gas and water vapor. Here we say that new substances are formed. For example, carbon dioxide gas and water vapors are formed from the reaction of glucose and oxygen. Therefore, we define chemical change as the type of change in which one or more new substances are formed is called chemical change, like burning of food, digestion, respiration, etc. Thus noted down all these examples. Now what is chemical reaction? Well, we know that when hydrogen and oxygen react together, they form water. This is the left hand side and this is the right hand side of the reaction. Hydrogen and oxygen is known as reactants and water is known as product. Here, two different substances react together to form one new product. Secondly, consider sodium plus chlorine react together to form sodium chloride. Here, again two substances react together to form one new substance. Thirdly, consider methane gas, which is burnt in the presence of oxygen gas to produce carbon dioxide plus water vapor. Here, two different substances react together to form two new substances. So we define chemical reaction as a process in which one or more substances react together to form one or more new substances is called chemical reaction. Let me repeat it. A process in which one or more substances react together to form one or more new substances is called chemical reaction. So these all are the examples of chemical reactions. Now what is a chemical equation? Well, consider a chemical reaction. Hydrogen and oxygen gas react together to form water. Here, remember that one hydrogen cannot exist independently in the nature, so I write 2 here as a subscript. This H2 means one molecule of hydrogen gas. Similarly, the symbol of oxygen is O. It also doesn't exist independently in the nature, so I write here O2. Lastly, we know that the formula of water is H2O. Thus we represent this chemical reaction in their respective symbols or formula. So this format of a chemical reaction is known as chemical equation. Therefore, we define chemical equation as the symbolic representation of reactants and products in a chemical reaction is called chemical equation. Let me repeat it. The symbolic representation of reactants and products in a chemical reaction is called chemical equation. Remember that many students do not know the difference between chemical reaction and chemical equation. So note it down that this is a chemical reaction and this is a chemical equation. Now how can we balance any chemical reaction? Firstly, let me teach you some basic concepts. Let I write H2 and 3H2. Here, this 2 is a subscript and it means 2 hydrogen atoms. Here, this 2 is again subscript, but this 3 is a coefficient. Remember that this 3 means 3 times H2, or we just multiply 3 into 2. We get 6 hydrogen atoms. Now consider these 2 compounds. Here, 3 into 2 is equal to 6. So there are 6 iron atoms. This 3 is also the coefficient of oxygen. So 3 into 3 equals 9. Hence there are 9 atoms of oxygen. Secondly, here is 1 calcium atom. This 2 means 2 with oxygen and 2 with hydrogen. So 2 atoms of oxygen and 2 atoms of hydrogen. Hence noted down all these basic concepts. Now consider this chemical equation. I write here hydrogen gas, oxygen gas, and in case of H2O, I write them separately. H2.O. Usually, in such type of reactions, I start from either hydrogen or oxygen. Now here, according to the law of conservation of mass, at the left hand side, there are 2 oxygen atoms. At the right hand side, there is 1 oxygen atom. So I put here 2 with this oxygen. So oxygen is balanced. Now listen carefully. This oxygen is attached to hydrogen and H2O. Let me repeat it. This oxygen is attached to hydrogen and H2O. Here, if I put 2 with oxygen, I have to put 2 with hydrogen. Now 2 into 2 equals 4. There are 4 hydrogen atoms at the right hand side. We can see that there are only 2 hydrogen atoms at the left hand side. So I put here 2. 2 into 2 equals 4 hydrogen atoms. So hydrogen is also balanced. Lastly, I take 2 as a common from hydrogen and oxygen and I write it here. So this is balanced chemical equation. Now consider this chemical equation. I write here magnesium, oxygen gas, and then magnesium dot oxygen. According to the law of conservation of mass, there are 2 oxygen at the left hand side and there is 1 oxygen at the right hand side. So I put here 2 and oxygen is balanced. We know that oxygen is attached to the magnesium. I also put here 2. Now at the left hand side, there is 1 magnesium and at the right hand side, there are 2 magnesium. I put here 2 and magnesium is also balanced. Lastly, I take this 2 and write it here. This is a complete balanced chemical equation. Thirdly, consider this chemical equation. I write sulfur dot oxygen, oxygen gas, and sulfur dot O3. Now at the left hand side, this 2 oxygen and this 2 oxygen equals 4 oxygen. At the right hand side, there are 3 oxygen. In such type of 4 and 3 or 2 and 3 cases, I start balancing from smaller side. The smaller side is 3, so I multiply oxygen by 2. I have to put 2 here with S. Now at the left hand side, there is 1 sulfur and there are 2 sulfur at the right hand side. So I place here 2 with sulfur. Sulfur is attached to oxygen. I place 2 with it. Now 2S, here is S balanced. Secondly, 2 into 2 equals 4 plus this 2 oxygen equals 6 oxygen. At the left hand side, there are already 6 oxygen. This 2 into 3 equals 6 oxygen. At the right hand side, there are also 6 oxygen. So oxygen is also balanced. I also take this 2 and write it here. So this is a complete balanced chemical reaction. Lastly, let me show you that how I can use this trick to balance any chemical reaction easily. Consider this difficult question. I write here iron H2 dot oxygen, iron 3 dot O4 and H2. Here are 4 oxygen and there is 1 oxygen. I put here 4 and I also put here 4. Oxygen is balanced. Secondly, 2 into 4 equals 8 hydrogen. Here are 2 hydrogen. I put 4 with hydrogen. 2 into 4 equals 8 hydrogen. Hydrogen is also balanced. Thirdly, here are 3 iron atom and there is only 1 iron atom. I put here 3 with 8 and iron is also balanced. Now I write here 3, 4 and 4. This is a complete balanced chemical equation. Therefore, using this trick, we can easily balance any chemical reaction. Now let me teach you the 8 types of chemical reactions. Well, the first type is combination reaction. The word combination shows that when A plus B combine together, they form AB product. For example, carbon plus oxygen gas combine together to form carbon dioxide gas. So we define it when 2 or more reactants combine together to form a single product is called combination reaction. The second type is decomposition reaction, like AB breaks down into A plus B. For example, aluminium oxide decomposes into aluminium plus oxygen gas. So we define it when a single compound breaks down to produce 2 or more substances is called decomposition reaction. The third type is displacement reaction, like A plus BC react together to form AC plus B. Here, A displaces B. For example, potassium plus sodium chloride react together to form potassium chloride plus sodium. Here, potassium displaces sodium. That's why we call it displacement reaction. Hence, we define it a reaction in which more reactive element displaces less reactive element from its compound is called displacement reaction. The fourth type is double displacement reaction, like AB plus CD react together to form AD plus CB. For example, HCl plus sodium hydroxide react together to form sodium chloride plus water. So we define it as a reaction in which 2 elements are exchanged between 2 compounds is called double displacement reaction. The fifth type is oxidation reaction, a reaction in which oxygen is gained or hydrogen is lost or electron is lost is called oxidation reaction. For example, magnesium plus oxygen react together to form magnesium oxide. This is oxidation reaction because magnesium gains oxygen. The sixth type is reduction reaction, a reaction in which hydrogen is gained or oxygen is lost or electron is gained is known as reduction reaction. For example, copper oxide plus magnesium react together to form copper plus magnesium oxide. Here, copper is reduced because it has gained electrons. The seventh type is redox reaction, a reaction in which both oxidation and reduction occur simultaneously is called redox reaction. For example, aluminium plus oxygen gas react together to form aluminium oxide. Here, aluminium is oxidized and oxygen is reduced. So this is an example of redox reaction. The eighth type is neutralization reaction, a reaction in which acid and base react together to form salt plus water is called neutralization reaction. For example, HCl plus sodium hydroxide react together to form sodium chloride plus water. Here, HCl is an acid, sodium hydroxide is a base, and sodium chloride is a salt. Thus noted down these 8 different types of chemical reactions. Here, let me teach you one bonus concept. Remember about exothermic reaction and endothermic reaction. The word exo means outside, and personally I say exo means exit, and the word thermic means heat. So a reaction in which heat is released or given off to the surrounding is called exothermic reaction. For example, calcium oxide plus water react together to form calcium hydroxide plus heat. This is exothermic reaction in which heat is released. Secondly, the word endo means inside and the word thermic means heat. So a reaction in which heat is absorbed from the surrounding is called endothermic reaction. For example, nitrogen gas plus oxygen gas react in the presence of light to form nitric oxide. So this is an endothermic reaction because nitrogen gas and oxygen gas absorb heat from the sunlight to react and form nitric oxide. Lastly, let me teach you the characteristics of chemical reactions. The first characteristic of chemical reaction is evolution of gas. For example, when sodium reacts with water, it forms sodium hydroxide and hydrogen gas. So in this reaction, hydrogen gas is produced. Secondly, change of color. Remember that color change in a chemical reaction due to formation of new substances. For example, copper sulfate plus iron react together to form copper plus iron sulfate. The color of copper sulfate is blue and that of iron sulfate is light green. So the color of copper sulfate changes to blue when it reacts with iron. Thirdly, formation of precipitate. And we usually use the word PPT for precipitate. When we add a few drops of ammonium hydroxide to aqueous solution of iron chloride, brown precipitate or brown PPT of iron hydroxide is formed. Fourthly, change of state. For example, electrolysis of water produces hydrogen gas and oxygen gas. Fifthly, change in temperature. For example, when calcium oxide plus water react together, they form calcium hydroxide. The container or the system becomes hot. It shows that the temperature of the system is changed. So these are the 5 characteristics of chemical reactions.